Listeners. Hey, good afternoon, everyone. Thank you for the office hour session. Today, we're going to do several things. First of all, I will go over the exam posted on Canvas, just quickly go over that. So to answer some basic questions. I will not give you the numbers, but at least will lay out some directions for you guys to follow and compare your results in a qualitative way. Okay. So after that, we'll get into the Q&A. So if you have any specific questions, welcome to ask me and we can discuss where we're at it, okay? Without further ado, let me share my screen so we can see the content. Give me 1 second here. Let's see if I can do this properly. Hold on a second. Okay. Let's see if I can pull it out here this way. Share screen. All right. So do you guys see the screen right now?
Yeah.
Okay, good deal. So this is the exam posted there. So let's take a look at the first problem, right? So a value of beta 1 to 0.7 corresponds to the specified concrete compressive strength. Pick the numbers here. You have that equation, which is 0.85 minus or 0.65 plus. So remember, every 1,000 psi, you lose 0.5 from 8,000 psi. So take a look at the numbers, right? I think you can do this one. It's just basically the beta 1 equation you need to worry about, okay? So I think that's that, not difficult. The second one, which is the following statement is correct? Unit weight of reinforced concrete and unit weight of steel, which one is higher? Of course, right? Unit weight steel is much higher, right? So which is the time for the normal concrete cylinder test to be evaluated at? So 7, 14, 28, 365. Normally we go with 28 days, right? So answer C here. Now, which is the following statement is correct? Well, tensile strength is equal compressive? Definitely not. It's asymmetric. Tensile strength of the concrete is approximately 33% of compressive strength concrete. 33%, that's too high. Okay, 1% is too low. So you figure out, right, which one is the correct answer here, right? So 1E, for a given reinforced concrete beam with strain and extreme tension layer of reinforcement epsilon T, note that this is epsilon T here, 0.03, a nominal flexure strength, the strength reduction factor is, well, using the phi equation, right? So this is between 0.02 and 0.05. So definitely between 0.9 and 0.65, rule out A, rule out B. You have B and C, so you have to plug in that equation, find out which one it is. All right, 1F, for all value F prime C equivalent to rectangular stress block, that is the Whitney stress block. In exam, I would just say maybe Whitney stress block, okay? So which one correct? At height of 0.85 of neutral axis depth C at a nominal flexure strength. So this is A equal to 0.85 C, which you know is not right because that should be a beta 1 C. Beta 1 is dependent on F prime C, right? B has the same area as the actual concrete compressive stress distribution and nominal flexure strength might be, right? Has the same centroid as actual compressive stress distribution and nominal flange strength might be, right? Because that's the equivalency we're talking about, right? So A is out, B and C, so naturally D here, right? So 1G, for a precast concrete beam that is exposed to weather or in contact with ground. So this is different environment conditions. One's interior, one exterior. And what is the minimum cover specified by ACF 1819 or 2 tables? Okay, check out the 2 tables. When you check out the 2 tables, there are stirrups related information. Remember, this is number 3, reinforcing bar for stirrups. Okay, so pick a number here. 1H, you have configuration A, configuration B. So the difference between A and B is that both, well, actually the similarity between them are both have 2 rows of reinforcement. One has a number 5 in the first row on top. The other has number 10 first row on top. So it's kind of a bit heavier set for A, right? Which means the centroid of the group of bars is lower, right? So you think about that. So if the centroid of the group of the bars is lower, meaning it has a higher ds, right? And you remember the equation for moment Mn equal to ASFY multiplied by a bracket inside ds minus half A. So a deeper D beam usually indicating a higher moment capacity, right? So you know which one to pick. Okay, so in the exam, be careful. I may play it reversely, right? I may ask you which one has a lower moment, right? So, or I can make the configuration into the reverse way, because this is for positive bending moment. Okay, be careful here, positive bending moment. What if it's for negative bending moment? Okay, think about it. Think about it. All right. When I consider cross section below, this is very typical. You know the cracking moment, how to calculate that, FR. Y over ICR, right? Things like that, sorry, IGT, things like that. And D, which is DS, okay? If I don't write anything here in the subscript, DS, D is DS, all right? DT is the depth of the last layer of the bar. For this one, is basically the depth of the number 8 bars at the bottom here, and B mean, okay? Check B mean. There are two ways of doing B mean. One is the actual calculation we showed you in the lecture. The other is check with the table, right? Table A5. Now, which one you use? You use the hand calculation. You use the hand calculation. Of course, you can compare this number with table A5, but be careful, right? Sometimes table A5 may not work, All right, problem number 2, this is the simply supported beam has the concentrated force and the distributed load, right? Be careful, the distributed load is dead load, so that is 1.2, and the live load is 14 kips, means this live load 1.6. So when you do the moments, you have to calculate the moment separately, right? This is the MU we're talking about. So MU should be equal to the distributed load cos the moment MU dead multiplied by 1.2 plus the moment induced by the live load, which is MU live and multiplied by 1.6, and you add them two together, right? So that is how we calculate MU here. 2A, determine the nominal strength and end of AA reinforced section. And highlight AA reinforced section, right? You have compressive reinforcement as well, right? So everything is given in this problem: geometry, the bar configuration. So this is more of an analysis problem. Okay, no design for this one. This is analysis problem. Okay, now mind you that it says that if the iterative procedures used perform at least 3 iterations, that means you try 3 different depths, different compressive zone size C. Okay, you try at least 3 different compressive zone size C to get your answer. All right, to be to draw the strain distribution and highlight strain distribution. Okay, you have to figure out what is the strain look like. What does the strain look like? Okay, and nominal strength for the section. Okay, and label the key value of the strain. So what are the key values? Epsilon Cu, which is the compressive strain of the concrete, 0.003, and then the strain at the tensile bars, the first level and second layer, right? 2 layers of the strain, okay? And the depth of neutral axis in the diagram, in the diagram. So how do we draw the strain distribution, right? How do we draw the distribution? So if I can annotate, you think of it, right? So it basically looks like this, and I have 0.003 here. That is locked, right? So from step number 1, when you do an analysis, you will find out the height. You will find out the compressive zone size C here. Once you find compressive zone size C, then you should know this angle right here by the triangle, right? And you can find out the strain at different levels. Okay, and don't forget, not only you have the tensile strain, you have epsilon layer 1, epsilon layer 2, but also you have a compressive strain, epsilon S prime right here. Okay, so remember you have 3 strain levels for reinforcement. 3 strain levels for reinforcement. Okay, so that is for 2B here. All right, 2C, verify whether the area reinforcement provided meets the minimum requirements AS mean of the ACI 318 codes. So those are the 2 equations: 3 square root of prime C Fy BWD and 200 over Fy BWD, right? Pick out the higher number of those 2 equations, right? Now, if the beam is subject uniform service load and concentrated service load, right? Dead and live, as I described before. So this is to compare your MN with MU calculated, right? To see which one is higher, right? Which one is higher, okay? So determine whether the beam is adequate or not, okay? Now, the last problem, problem number 3, and first of all, you look at this geometry, right? It's a pole. It's a pole, vertical member, right? But actually it's a beam because I'm pushing at one end. So I bend it like this, right? Bend it towards right. So when I do that, we exert a moment max at the end of the support here, right? But be careful when I push down this way, right? I'm bending it in a negative direction. That means if I draw the section, right? So if I draw this section right here, like that, right? I draw like that, right? So you think about the bar should be on the tension side, right? So when you design the section, you have bars, and I'm putting 2 bars here, not necessarily meaning only 2 bars, right? You may end up with 3 bars, that's up to you, right? But when you draw that, you also need to draw the stirrups around it, right? You need to draw the stirrups around it, and also give me the spacing, right? Give me the details, right? What is the spacing, and then find out whether this section actually checked out in terms of beam in or not, right? Checked out whether this is beam in or not. So things like this need to be checked for your sections. Okay. Now going back to the question, take a look at this question 3A here. If the width B is restricted 10 inch, design a rectangular concrete pillar section where the maximum factor moment is acting, which is here. Okay. Now knowing that MU is factored already, so you don't have to worry about the factor, right? You can use this number directly. Okay, all right. Now another thing is that this is singly reinforced, tension controlled. Keywords: tension control, 1 layer reinforcement tension, and this is actually single layer. So tension controlled, meaning that epsilon T, that layer has to be greater than 0.005. Okay, this has to be satisfied. Okay, and now also only number 8, 9, or number 10 bars are to be used. You cannot use other bars. All right, assume the centroid reinforced to be 2.5 inch from extreme tension face of the curl section. So this is saying that we will fix the centroid of the reinforcement. That means that if I have tensile layer and this is 1 layer, right? Meaning that from the center of the reinforcement to the bottom or for the tension face, this distance has to be 2.5 inch. This is given, okay? This is given, you have to work under the confine, right? You cannot work outside the confine, okay, within the confine. So from extreme tension layer and cross section, determine phi mn. So phi is the strength reduction factor. Be careful, okay? But think about this, right? This is already 0.005. So think about your phi, okay? And perform all the necessary code checks. That means details, right? That means detailing, right? Detailing. And in this case, since most of the bars are in 1 layer, so there won't be any spacing in between layers. So the only thing you have to worry about is basically beam in, okay? Minimum beam cover beam in, okay? So that is what we need to do, all right? After everything's said and done in 3A, all you have to do is draw it out in 3B, okay? Draw it out in 3B, okay? All right, so you see that it's pretty clear. I don't think it's difficult example, right? Difficult exam. And now, the only thing I haven't covered in this exam is the irregular section, okay? Now, for the irregular section, although I haven't shown example, I can tell you now, it won't only be for irregular section, will only be so irregular section, let me just use IRR in short, I'm lazy in terms of writing, so this only will be in terms of analysis. I will not ask you guys to do any calculation in terms of design. No design, okay? Only calculations for analysis, meaning I will give you a section, right? Either can be this with an opening, something like that, or it can be something like I-beam, okay? And just for the sake of fun, I might also have an opening in the middle of it, okay? And also might be a T-beam, but that's it. No irregular shape, right? Just a T-beam. So either going to be irregular shape or T-beam. I will pick one. Okay, for this example, I'll pick one, okay? So now with that, I think we'll have total of 4 problems. Okay? And now for the T-beam, but be careful, if I show you the T-beam, I may ask you to pick out the effective section. So meaning from the homework, you have done that, meaning I will give you this drawing like this, right? And ask you to determine the BEFF, right? Effective width, that is BE, right here, equal to BW, which is the web width, plus 2 times the wing width, BF, right? I probably ask you to do that, and you use this number for your section and do your analysis, okay? And when I say a T-beam, and that is still analysis, meaning I will provide a reinforce, so I'll tell you how much exactly we'll put it there in terms of steel, okay? So these are the new information. So it's either going to be this configuration or this configuration or this configuration. I can tell you right now, it's going to be one of the 3. Will not be otherwise, okay? I can tell right now will not be otherwise. It's either one of the three problems, okay? So which one? I don't know yet. I am deciding right now and checking my answers. So you need to go back to notes and take a look at how we did this one. And this two, we haven't done exactly like this, but the method still applies. Think about the one we did in class. That's actually even harder. Okay, think the one we did in class is even harder. So that's kind of similar to that. So that is what we're going to do for irregular and TB. Okay, for irregular and TB. All right. Well, with that, I basically cover everything I want to say about this exam, and I'm ready for questions. Anything?
I had a question about that irregular cutout shape that you said that we did in class.
Sure.
The one you just drew that you said was harder.
Yeah.
Specifically the area A3. I see that we have it listed the same as A1. That makes sense. But then when we get into our y-bar equation, I think I'm missing it there.
Oh, okay. So when we do the y-bar, right, you're using AC, right? AC, that's the total compressive area, right? So that equals A1 plus A2 plus A3, right?
Yeah.
So A1, A2, you know that, right? You already know it. This is 1, you calculate out, right?
Yeah.
And by separation, 2 is before you do the cutout, right?
Okay, yeah.
So you have to determine A3 first. And in a note, I call it 3 prime.
Yeah, that's the one that's what I'm missing.
Right, so you know how to calculate AC? Do you know how to calculate AC?
Oh, yeah, okay.
Right. So AC is 70.6 inch square, that is known. Can't remember the number exactly, 76 or 70.6 inch square, but that is known because that has to be the ASFY, equal to tension, right?
Yeah, okay,
Right.
so that AC equals A1 plus A2 plus A3 prime.
That's right.
All right.
Got it?
Yeah, that should be all I'm missing. I think I was just missing that prime symbol.
Yeah.
All right.
Yeah. Okay. Any other questions, folks? Any other questions?
I have a question about finding like the minimum like base width and such. I'm having trouble with that. Like I was trying to do some on the homework and I was getting a very greater answer. I think it was because of the stir rods and such, stirrups.
That's about homework, right?
Yeah.
Okay. Well, if it's about homework, we can wait a little bit and I can clear out the exam.
I was just mentioning it because I'm kind of unfamiliar with how that affects, like especially with some of the other earlier problems. I think have the stirrups in there and such. So
right, no problem. We can get to that. Okay, but let's see if anybody else has any question about the exam. Any question about the exam?
I had a question about what we were allowed to bring. So for the crib sheet, is it 1 page front and back or just front?
Other side, front and back.
Okay, cool.
Yeah, so A4 print paper, letters, paper, white sheet, and front and back. You can do cutout, print, glue, write anything you want, doesn't matter.
Cool.
Yeah. Okay. Anything else, folks? Anything else about the exam? Okay, well, if anybody, Bo?
Yeah, I guess kind of feeding off of what the other guy's question was with that beam in value. You mentioned that with our beam design being the limiting factor. Could you go, I guess, so would it be constrained? Like, would you give us the constraint or would we?
So you think about it, right? You're talking about this problem. So think about it. If beam width is restricted 10 inches, right? Do you see this?
Okay, yeah.
So what you need to do is you calculate your beam in depending on how many bars you have in the section, right? You can do that. Can you?
Yeah, okay.
Yeah, so now you have B min, you have 10 inches. So all you have to do is see if the B min is bigger than 10 inches. Right?
Yeah, that makes sense based off of our like cover and stirrup, the stirrup size.
Right. Right. So you think of it, right? So maybe I can answer right now in a more of a approach way while we're at it, and I can also answer the specific homework problem. But let me do that to clarify any doubt for the exam. So you think of it, right? Basically, what you're trying to do is you have the concrete cover, right? This is called clear cover. You can find it from table, right? ACI table. Okay.
All right.
Right, and then you have another thing. It's called the stirrup size, right?
Yeah, and widths of 8s.
Yeah. So 3/8, right? Then number 3 bar is 3/8, right?
Okay.
Right, and then you have a bending radius of the bar, right? So that is dash line is invisible, but that's how we bend the stirrups, right? Remember? And from the center of the bending radius, which is actually lined up with the corner bar here, you have a 2ds. From the notes, ds is the diameter of the stirrups.
Okay.
Okay. Now after that, you have this half of bar size, right?
Yeah.
And then you have a minimum spacing between this bar and whatever bar you have in the middle or on the side.
Yeah, like CS.
Right, right. Now after that, you have to consider this bar size, right? And if you only have 2 bar, then you just have to worry about the stirrups again, right? So it's symmetric. Is that right?
Yeah. What is so I guess you said 2DS.
Yeah. So 2ds is what? So you need to go back to the notes, right? Take a look at the detailed drawing, right? So when we have 2ds, we say that when you have a stirrups, the stirrups it's like a bend, right? A bend here.
Yeah, I was looking at doing it with 1DS and then an S hat being taken into consideration, that radius.
That's fine, but if
The
you
same.
calculate S hat, you can still do it, right? Let me explain to you how. Because when you have a stirrups, you can bend like this, right?
Yeah.
Okay, so when you bend like this, you need to have a centroid or center, right? To bend like a radius, right?
Yeah.
Right. So when you bend it, right, it's actually a bending machine, and there's a big giant steel disc that your bar is surrounding around it, right? And then you bend like that. Is that right?
Yeah. Okay.
So that radius from inside the wall to the this is called center, right? Bending center here is two times of the diameter of the stirrups. That's where the 2ds coming from.
Okay.
Right. Now, when you have that, remember you still need to put your bars there, right? And you need to put your bar, tie your bar to the stirrups. You need to secure that bar in the corner, is that right? Or else the bar is gonna rolling around, isn't it?
Yeah.
So to make sure it lays horizontally, the bar will sit like this, actually. Okay, so why? Because we often align the bending center with the center of the bar.
That makes sense. Okay, so they're level all the way across.
That's right. So that's why this distance here from the inside wall of the stirrups to the center of the bar is 2ds. Get it?
Yeah. Yeah. That's perfect. Thank you.
Yeah. So S hat is just a clear gap between the inside of the stirrup to the edge of the bar. That's just another way to do it, but I just want to show that this has to be positive.
Okay. So then using the 2DS, we just count over half the diameter of the bar. Keep going and going. Okay.
Right. Same thing.
Makes sense. Thank you. Perfect.
No problem. Alexander, does that answer your question?
Partially, yes.
Yeah, I can now check the number if that's what you're after, okay? I can tell you.
I mean, no, I'm not after that. I was my concerns mainly with just like getting the whole B minimum, given there's like at least like another bar that we have to like go across to get the minimum.
Another bar go across.
Yeah, like if there's say there's 5 bars singly reinforced, then it stretches beyond just 1, and so there's not just the 2ds, but then.
All right, let's show you, right? So do you see it?
Yeah.
I'm going 5 bars here, right? So first thing you do is that you have steroids going through this way.
Right.
Okay, let me finish this drawing here. It's going to be a little bit tricky. I don't want to do it right. Okay, give me 1 second. Okay, there you go. All right, so this is what you're talking about, 5 bars, right? And this is the edge of the concrete. And now look at, first thing you do is find the centroid. Center line here.
Right.
Okay, now the problem becomes just need to calculate half of the width. All right?
Yep.
Okay, so now you have this thing, as we talked about, the whole thing set up here, right?
Right. Yeah. And
So let's just say on the left-hand side, you got it taken care of. Can you do that?
Yeah.
Right, so that we talked about how to do that, right? 2ds plus a half dB, and you're there. dB is the diameter of the bar.
Right. Yep. And then
Once
with the
that
concrete cover.
right, that is once that is done. Now the CS is the minimum spacing between bars in the horizontal direction, right?
Yeah.
And that has 3 choices, right? 1 inch and 4/3 of dB. And then what's the last one? dB. dB bar size, right?
Right.
And you need to pick the largest, right?
Yeah. Largest of.
Right, so the maximum of these 3, right? Okay, and I'm just gonna say that this is not dB, okay? This is our B aggregate. Let me make a correction here.
Yeah, that makes more sense now. Yeah.
All right,
But
yeah. So let's just say that somehow we're lucky and get this to be 1 inch, okay? Right,
So
so
then-
I'm using number 8 bars, and I got lucky. This is 1 inch, okay? And if that is 1 inch, and I'm using number 8 bars, right? The diameter of number 8 bars is 1 inch, right? Do you follow?
Yep.
Yeah, okay, so now CS is 1 inch again, right?
Yep.
So now assuming whatever you have here, let's just making things up. I don't know what's your exact number. Let's just say it's 4.5. I'm making things up, okay? Which is a very large number, but let me just say this is 4.5, okay? All right, so from edge of the concrete to the edge of the first bar, as you just computed, and assuming that's what you have right now, okay? And you have 1 inch, another 1 inch, and then half bar to the center line here, right? So this is what?
Right. Yeah.
5.
Yep.
So how much you have? 4.5 plus 1 plus 1 plus 1, so 3.7, so 7.5, right? 7.5 plus 0.5, 8 inch, is that right?
Mhm.
And this is half of the B mean, right?
Right. Yeah.
So what is your B mean?
So that's 16 then. Yeah.
And there you go, right? So if you got 16 inches here, let's just make an assumption that for this problem, somewhere I got 16 inches, right? Does that work for you?
No, it does not. No.
Right, so it cannot be using 10 inches.
Right.
There is something wrong with your design, right?
Right. Yep.
So
And then just a quick check on the concrete cover and such. So for singly reinforced, it's 2.5 inch.
No. That is for the bottom cover, right?
Right. Oh,
We're talking about the side cover. There's a table in ACI dictates how much you need, right? There's an exposure, interior exposure, exterior, precast, contact in the ground. You missed that lecture.
no, I didn't. I think I was reapplying it in the wrong direction.
Yeah, there you go. Usually it's 1 to 1.5 or 1, okay?
Per cover. Yep. Okay.
Yeah, good. Okay,
And so then which table can I
go back to your notes and find out, okay?
yeah, I'm looking at it.
Here right now is 20.5.1.3.1, but double check, all right?
Right.
Okay. It's an ACI 31819.
Page 382.
Thank you.
All right, Alexander, that okay? Or other?
Yep, I think I'm okay now.
No problem, no problem. Any other questions, folks, on this detailing? This is very important. I think these are very valuable questions, okay? Very important.
I'm good. Thank you for holding this session.
No problem, no problem. Anything else, folks? Anything else? Okay, well, we're having a class meeting tomorrow, Wednesday again, right? If you think of anything else related to exam or homework, ask me tomorrow after class, okay? We can stay behind a little bit and go over some of the problems as well. All right. If nothing else, we're just gonna close out the section, upload this one to YouTube, and you can watch it later if you want to. But really start reviewing. There'll be 4 problems, okay? I repeat, for those of you who are watching from home, will be 4 problems, okay? 4 problems. The last problem is either gonna be an irregular section or a TB, right? I just draw it out and I will upload I'll upload this to YouTube. Okay. All right. Well, thank you guys. I will see you tomorrow. Okay. Bye now.